Good,
Start the class.
good evening, everyone. And this is lecture number 4 in wave optics. And as previous class, we are going to continue with Young's double slit experiment. And we had seen the Young's double slit experiment. We'll continue on this. This is the most important part of this, the major part of this. If any question comes, it will come from this part. Young double slit experiment, we had one source. From that one source we had created two sources using law of two sources, and those two sources are interfering on the screen. We created those two sources by division of wavefronts. Do we understand this? Do we remember this? Then
Yes,
at
sir.
some points we have constructive interference. At the points where we have constructive interference, we have bright fringes. Yes or no?
Yes, sir.
At points where we have destructive fringes, we have dark fringes. Yes or no?
Yes, sir.
And we had seen some points about this was a diagram that we had alternate dark and alternate bright fringes. Yes or no? So we will
Yes, sir.
carry on with this. We were, I think, writing some points. We were writing some points on this, and those points were this. We'll continue with those points. And remember, these are the points which are going to come in the exam. Okay, so we had seen a couple of points. The first point was energy is conserved in interference. It is just redistributed. Dark points we have no energy, but at bright points we have the rest of the energy. If one of the slits is covered, we will not have any interference because it needs two coherent sources. Now, the third point was if white light is used, white light consists of 7 different colors. The violet fringe will be next behind the central fringe. The central fringe would be bright and the red would be farthest. This happens because wavelength of violet is small compared to the wavelength of red light. You will understand what effect this wavelength has in today's class, but this was the reason for the point that we had written. We will continue writing these points because you are very unlikely to get any question on base. A question will be simply formula based. You might get a theoretical question on this. So we move on with the next point. Now, this interference pattern obviously can be observed with white light, but normally whenever we are doing this YDSE, it is done with a monochromatic light. So YDSE or Young's double slit experiment is conducted with a monochromatic light. What do you mean by monochromatic light? What do you mean by monochromatic light? Monochromatic light means light which consists of only one color or only one wavelength. Do we understand this?
Yes, sir.
It should be always conducted with light which only consists of one color. It cannot be done with light of different colors. Do we understand this?
Yes, sir.
Okay. Now, if we have, I hope everyone is noting down. If one slit is illuminated by red and the other by blue, will you observe interference? If one slit is having red light, the other is having blue light, will you observe any interference?
No, sir.
We will not observe any interference because for interference to happen, we must have light of only one color or one wavelength. Do we understand this?
Yes, sir.
Next point, I hope everyone is noting down the points. Next point is central fringe central fringe is always bright if the experiment is conducted in this fashion. But sometimes the central fringe, which is bright, is going to shift. We will see those cases. Here I am just going to tell you one of that cases because I might miss it later on. Central fringe is always bright, but there are ways that it can be shifted. One of these is if the two coherent sources if two coherent sources are object, the one coherent source is the source itself, or instead of calling it the object, let me call it the source of light. If two coherent sources, we produce our source and its reflected image. I can produce coherent sources in this way also. I will have one source of light, let us say this, or if possible, I can show you that. Let me see if I have the image of that. I have that image. So it's better I show you this image. This is the image that I am talking about. This one. See, I have produced two coherent sources here. One is the source itself, and the second one is the image which is reflected from a mirror. This thing that you see is a mirror. Do we understand this? This is a mirror. So this way also I can produce two coherent sources. This is known as the Lloyd's mirror arrangement for YDSE. This is not YDSE. This is this is not double slit experiment. This is an interference experiment done with a mirror. This is known as the Lloyd's mirror. So in this Lloyd's mirror experiment, what is going to happen is we are going to produce two coherent sources in a different way. One will be the source and other will be the image of the source. Now, if we talk about the central fringe will come here. In this case, the central fringe will not be bright. It would be dark. It would be dark. So if two coherent sources are source and its reflected image, then the central fringe will be dark. I hope you understand it, bacha, what I'm saying.
Yes, sir.
So I'll give you 2 minutes to note this down. If you want to draw the diagram, you can draw the diagram because the diagram may come as question. So you can draw the diagram if you wish so. Let me know once you are done.
That's a
Okay, move on to the next point. All these points are potential question. Okay, the young double slit experiment is done with slits. I hope you understand the meaning of slits. Slits are cuts like this. We had seen it in the diagram that we had cuts like this. See, this is a slit. This cut is a slit. It is done with slits and it is not done with pinholes. So you do not conduct a Young's double slit experiment with pinholes. We conduct it with slits. Why do we conduct it with slits? I hope you understand the meaning of slit. Yes or no? This
Yes, sir.
Young's double slit experiment is conducted with slits because slits are more brighter than point sources. Slits are brighter than point sources. Slits are brighter than point sources. If the size of slits, if the size of slits are equal, then dark fringes would be completely dark, will be literally dark, no light. If they are of unequal size, then dark fringes will not be completely dark, because if they are of unequal size beta, the amplitudes will be different of the wave that they create, the intensities will be different, and therefore the minimum intensity will not be zero. Dark fringe will not be completely dark. Bright fringe will not be very bright. It will be bright, but not maximum bright. If they are of equal sizes, dark would be completely dark and bright would be completely bright. Do we understand this, everyone?
Yes, sir.
Give you 2 minutes to note this down. Please let me know once you are done.
Done, sir.
Well, then we'll have to draw this diagram of the arrangement of Young's double slit experiment. So what is going to happen? We have seen that when we have two covalent sources exactly of same size produced from a single source, we will have interference. This is the screen that you can see. Interference pattern would be observed here. Yes or no? Do you remember this? These are the two sources, the daughter sources S1 and S2. Do we remember this S1 and S2? Yes or no? I can't see you. Yes.
Yes, sir.
Okay. Then the terms that you must remember is this small d. The small d is the distance between the two daughter sources. This O is the midpoint, and this C is the place where you get the central bright fringe. Yes or no?
Yes, sir.
This is the place where you get your central bright fringe. Now, what we are interested to know is if you take any point P, which is, let us say, a distance y above point C, it could be taken y below point C as well. As you can see in the previous diagram, this one, you will have dark and bright fringes above C. You will also have similar dark and bright fringes below C. Do we understand this? Yes or no? So you can
Yes,
take
sir.
it, you can take it above C or you can take it below C. Normally when we do the derivation or do understand, we take it above C. So so y. So basically what we are supposed to find out is at what value of y, please remember, at what value of y will you get dark fringe? At what value of y will you get bright fringe? Do we understand this? That is the only concern that we have. That is the only thing that we are concerned about in this particular topic, the Young's double slit experiment. For what value of y you will have dark fringe, for what value of y you will have bright fringe. Do we understand this?
Yes, sir.
So basically we are supposed to find out for what value of y you will have dark or bright fringe. I'll just write it here. For what value of y you will have dark fringe, and for what value of y you will have bright fringe. That is the only concern that we have in this discussion. Now we should get this value of y in terms of the things that are known to us. What are the things that are known to us? One is the distance d between the daughter elements. One is the distance d, capital D, between the slits and the screen, number two. And the third thing that is known to us is the wavelength of the light, because it's a monochromatic light, it only has one wavelength. So the three things that we know are y, no, are d, small d, capital D, and y. What we don't know or what we want to find out is the value of y for which we have dark or bright fringes. Do we understand this?
Yes, sir.
Now, how are we going to find out that? We understand that at this point P, we are going to have interference. Interference from two waves which are coming. Can you see those two waves that are coming and interfering at point P? Can you see those two waves that are coming and interfering at point P? Yes or no?
Yes, sir.
One wave is coming from daughter S1. The other wave is coming from the daughter S2. Do you see these two waves?
Yes,
One
sir.
from S1 and one from S2. One is green and one is blue. They are not traveling the same distance. Yes or no?
Yes, sir.
They are not traveling the same distance. Therefore, they have path difference. We just have to calculate the path difference. What is the path difference? To find out the path difference, delta x, we call it a delta x. Do you remember delta x? We see both of them are not traveling the same distance. The difference in their distance would be the path difference. What is the path difference? Can I ask you now? Looking at the diagram that you have right in front of your eyes. What is the path difference between the two waves? What is the path difference between the two waves?
S2P minus S1.
The bigger distance is S2P. The lower wave is traveling more. If the point is taken above C, lower wave will travel more. If the point is taken below C, the upper wave will travel more. Yes or no? It's simple to understand. I've taken the above point, so lower wave will travel more. So the lower wave travels a distance of S2P. What is the upper wave traveling? It is S1P. Yes or no?
Yes, sir.
This is what you need to understand. I'll give you 2 minutes. Draw the diagram up till this point. Draw it. The only thing that we have to understand in this entire chapter is this diagram. Take your time to draw the diagram. Mark the thing that I point, that I have highlighted. I'll give you 2 minutes to do that. Please let me know once you are done. Please let me know once you are done, beta.
Done, sir.
Everyone has done this? Great. So the only thing that we need to understand here is we have to find the value of S2P minus S1P. Now this is all, after this is all maths and approximation. Let me now take this off so that things look a lot better. So this was the original diagram. So I have to find out S2P minus S1P. Now remember, I have taken the assumption that D is very large compared to small d. This screen is very far. Remember, in double slit experiment, the slits are very close to each other and the distance of the screen is very far. So D, capital D, that is why it is written as capital D. Capital D is very large compared to small d. Now, if capital D is very large compared to small d, what I have done here is I have drawn a perpendicular from S to L. I have drawn a perpendicular from S to L. Now, if the distance d is very large, can I say that if the distance d is very large compared to d, I can say that this S1P is approximately equal to LP, yes or no? Very large, very far. If I drop a perpendicular, this S1P will be equal to LP, yes or no?
Yes, sir.
Now, if these two are equal, when I say these two, I mean S1P and LP, if they are taken as equal because of the large distance, the path difference between the two becomes S2L. Yes or no? Whatever is remaining, chota sa part. Do we understand this?
Yes, sir.
That is what you need to remember, that this path difference, which is actually equal to S2P minus S1P, can be taken approximately equal to S2 into L. Do we understand this?
Yes, sir.
Now, the value of this S2L, you can see that this is a right angle triangle. This is a right angle triangle. The value of this S2L, The value of this S2L is actually equal to d sine theta, where theta is this angle. Do we understand this?
Yes, sir.
I want you to note it down. Till that time, I draw my version of the diagram to make you understand it in a have you noted it down, beta?
That's sir.
Okay, so what I mean to say was this is the same diagram in my thing. So the path difference is S2P minus S1P. What I have done here is I have dropped a perpendicular L. This is 90 degrees. So I can write S2L is the path difference. This S2L becomes my path difference. Do we understand this? This angle I have taken as theta, my dear friends. This distance is your small d, and S1, S2L is the right angle triangle. So I can write this path difference as d sine theta. Do we understand this, my dear friends?
Yes, sir.
This path difference is d sine theta. That is what you need to understand. Now, this path difference is d sine theta. Now again, this entire thing is all about approximation, and I can't help it. This entire thing is about approximation. D is very large compared to capital D. Now I'm going to draw one more line, tongue, 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 tongue. And I will call this angle also as theta. Both angles, this green angle theta and red angle theta, are actually not equal, but because the distance is very large, we can take them as equal. Do we understand this? The red theta
Yes,
and
sir.
green theta are not equal, but because the distance is large, we can approximately take them as equal. Okay, so your path difference is d sine theta. This is the first thing that you must remember. This is the actual answer. Path difference is d sine theta. Okay, now again we take one more approximation. I have taken up till now one approximation that d is very large. I am taking the second approximation. Second approximation that I am taking is if theta is very small. That is the second approximation I am taking. If theta is very small, your tan theta becomes equal to sine theta becomes equal to theta. We know this, yes or no? If theta is very small, I can take sine theta equal to tan theta equal to theta. Yes or no?
Yes, sir.
Then my d sine theta, which is the path difference, becomes equal to d tan theta. Yes or no? Sine theta ki jagah I have put tan theta. And the value of tan theta, if you look closely, my dear friends, look at this PC line and look at this OC line, PC and OC, and look at the value of tan theta. You can tell me that, sir, the value of tan theta is y divided by capital D. Yes or no? Yes or no?
Yes, sir.
And that is your path difference. So path difference, ka shortcut formula becomes this. So there are two things that you must understand. Two ways in which I have written path difference. I'll give you 2 minutes. The first way in which I have written path difference is the actual way. The actual way of writing the path difference is delta x. The path difference is d sine theta. The next way of writing the same path difference, if theta is very small, I can write path difference as d tan theta. Are you getting me, my dear friends? Bacho. Then once I've written this, the third way of writing the path difference becomes delta x is equal to d into y by capital D. I'll give you 2 minutes to note this down. This is the most important aspect of this chapter. Do we understand this, bacha, what I've written? If you have any confusions, beta, please ask. I have taken two approximations. Please remember the two approximations that I have taken. The first approximation is small d is very small compared to capital D. The second approximation is angle is small, so your sine theta becomes equal to your tan theta. These are the two approximations I have taken. If you understand these approximations, rest of the case is pretty simple. I'm giving you time so that you understand this concept correctly and remember it, because everything is based on this concept, how quickly and how effectively you can remember this, because we are expecting a question of this nature coming from this chapter, this particular topic. That is what I mean to say, from wave optics. So note this down carefully.
That's it.
Everyone, sir? Okay. Then that takes us ahead. And what do I mean by ahead? Now, remember, we need to find out the main task that we had was to find out whether where we will have dark fringes and whether you will have bright fringes. Yes or no? That was
Yes,
the
sir.
main intention. Now, for bright fringes, for bright fringes, that means we have constructive interference. Do we understand this? For bright fringes, that means constructive interference. If you remember, the path difference was n times lambda. Yes or no?
Yes, sir.
Now the value of delta x that we have achieved is d into y by capital D. That must be equal to n times lambda. From here I can get the value of y. Y will be equal to capital D by small d, or I should write it in this way, that is better, n times capital D by small d into lambda, where n is a number and n starts from 0, 1, 2, 3, and so on. For n is equal to 0, I get the position of bright fringe. For n is equal to 0, I get the position of central bright fringe. Do we understand this? So central bright fringe will always happen at the center. If I put n is equal to plus 1, I will get position of upper first bright fringe. Do we understand this?
Yes, sir.
If I put n is equal to minus 1, then I will get the first bright fringe in the lower region. Do you understand this, what I'm saying here?
Yes, sir.
Well, I will again show it to you here in the diagram that I hope you have noted this down. Yes or no? No? Note it down. Note it down. I'll give you time. Note it down.
Done, sir.
Everyone, sir? Okay. So we have noted up till here, and I'll just show you in the diagram so that it becomes absolutely clear. You can also, if you have drawn the diagram, you can also note it. Let us get back to the diagram that we had drawn. And now I will write the values of n for bright fringe. This one will be n is equal to 0. Do we understand this?
Yes, sir.
N is equal to plus 1, n is equal to plus 2, n is equal to plus 3. N is equal to minus 1, n is equal to minus 2, n is equal to minus 3. Do we understand this? Yes or no? No, yes.
Yes, sir.
These are bright ones. These are the bright fringes. Let us go back and see what happens with the dark fringes. So same thing happens with the dark fringes, my dear friend. There is no prizes for getting this one. For dark fringes, let me use a different color. For dark fringes, tell me for dark fringes what will happen. Dark fringes means destructive interference. What should be my delta x equal to? Tell me fatafat. It will be equal to
2n
2m.
minus 1
I'm
lambda
not
by 2.
writing n, I'm writing m so that it just look different. If I use n both places, you might get confused what is happening, sir. So 2m minus 1 into lambda by 2. Are you getting me this?
Yes, sir.
So part difference is d by capital D into y. That will be equal to 2m minus 1 into lambda by 2. I will write it in this fashion. 2m minus 1 into lambda by 2 into d by capital D. When m is equal to plus 1, I will get upper first fringe, upper first dark. If I put m is equal to minus 1, I will get lower first dark. Do we understand this? Yes or no?
Yes, sir.
Please note it down. I'll give you a minute.
That's it.
Answer, then I will have you look at this one, which is the position of the bright fringes, and I shall use which color will work here. I think red will not work. Green. See, m, it doesn't work here. Let me try black. M is equal to plus 1. M is equal to plus 2. Do you see this? You understand this? Plus 3. Here m is equal to -1, m is equal to -2, m is equal to -3, and so on. I hope you understand what is happening here. Yes or no? No or yes?
Yes, sir.
Okay, so that is what you needed to understand. We will just note down the important points. What are the important points? Important point. Okay, before going into important point, let us do one more thing, which is known as fringe width. Fringe width. What do you mean by fringe width? It's the distance between two consecutive dark or two consecutive bright fringes. This fringe width is denoted by the legendary letter beta. The distance between two consecutive dark fringes or two consecutive bright fringes. Do we understand this? Yes or no? No or yes?
Yes, sir.
So basically, if I just show you in terms of a diagram, and that would be the best thing that I can do. See this diagram? You take any dark fringe or any bright fringe. You take the nth dark fringe or nth bright fringe, and then you take one ahead of it or one below it, n plus 1 or n minus 1, and you find out the distance between the two. That distance would be your fringe width. Do we understand this, or it has gone above or it's saying bye bye, bye bye, bye bye? Huh?
Understood, sir.
This is the bigger diagram for the same thing. You may not draw this diagram, beta. It is not for you to draw. It will take time. The only thing I am showing it to you is that you understand it. This is the bigger version of the same diagram. Bigger version of the same diagram. Do we understand this fringe width here, my dear friends? Ting 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 ting. Do you understand this?
Yes, sir.
Beta, the distance between two consecutive dark or two consecutive bright fringes. And what will I do? From n minus n plus 1, I will subtract n, or from n, I will subtract n minus 1. We already have the formula. I don't have to go into that formula. I will straight away give you the answer, and the fringe width is equal to d by small d into lambda. That is your fringe width, my dear friends. That is your fringe width, my dear friends. I'll give you 1 minute to note it down. Have you noted it down, my dear friends?
Yes,
Yes
sir.
or no? No, yes. Everyone. Okay, so this is what we need to understand in today's class. We will be writing some important points here. So before taking this away, let me give you one more formula and then we will call it a day. This is the formula for angular fringe width. This is the formula for angular fringe width. Angular fringe width. Now, what is this angular fringe width? Is better understood in terms of this diagram, and I will just show you this diagram. If you want, you can remember this. Remember, trust me, the diagram will not come. It'll only ask you the formula of angular fringe width. So you can just give this formula, angular fringe width. As you can see, my dear friends, this is the fringe width between two consecutive dark and two consecutive bright. The angle that it makes it with the center point, that is known as the angular fringe width. Do we understand this? This angle alpha can be written as this width beta divided by d, or you can write it as lambda divided by small d. This is known as your angular fringe width. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay, so just note it down. I'll give you time to do it.
Done.
Done, sir. Then we will call this a day, sir. What we have done today is we have seen most of Young's double slit experiment. In the next class, we will deal with the formulas and what all things are going to come into exam. And probably by the next class, we will wind up your interference, and we would probably from the next to next class jump on to your diffraction, and we'll try to finish your wave optics as soon as possible. So that is it from this class. Your time is also over. If there any doubt, you can always come up to me. Take care. Have a nice day. God bless all of you. Bye bye.